A very good evening to all of you. This is Shivam Shukla. Welcome back to my channel. And here I am to solve a problem on engineering mechanics. It's a problem on resultant of general force system, type 3 problem. To find the resultant force and its point of application with respect to a point on the x-axis, that is x-intercept, and y-axis, that is y-intercept. Let us see how the question statement goes. It's a question asked in May 2017. Question number 2A for 6 marks. December 18, 2B for 5 marks. Compute the resultant of the three forces acting on the plate shown in figure. Locate its intersection with AB and BC. You can see there are three forces acting in the system. 722 Newton, 622 Newton, 1000 Newton. All three are the inclined forces acting at some angles. Angles are not given. We should be able to find the angles with the help of the trigonometry formulas. Okay, so let's go to the solution of it one by one. So let us write down what are we supposed to find. So to find will be first r theta, that is magnitude, then direction, its location with respect to point B, that is perpendicular distance D. Now let us write, if I see the question once again, locate its intersection with AB and BC. So horizontal distance on BC it will be, and vertical distance on AB it will be. So we will assume those distances as x and y respectively. So let's write it down. Let horizontal distance on BC is equal to x, and vertical distance on AB is equal to y. So we have written it. Now step 1, let's draw the free body diagram of it. Step 1 is to draw FBD. So let's draw the free body diagram. So I'll start with this. So over here, the diagram that we are supposed to draw, a rectangle it will be. Like this. Even in the mid it will be over here. Okay. Now whatever the forces are there, so those I can draw it directly one by one. First of all, this is the first force that will be acting over here. Okay. I can draw it like this. What I can do is, first of all, I'll be showing this acting from here till here. Can extend this. This is of 622 Newton. Second one, from here till here it will be acting of 1000 Newton. Can check the questions diagram once again. And last is 722 Newton. Okay. So I can draw it over here. This is 722 Newton. So I can draw it, my dear friends, like this. So this was 722 Newton. Now since all three are the inclined forces as well as their angles are not given, so we are supposed to first of all find out the angles of all the three forces one by one. Before that, let's write down the dimensions of that particular plate. So here it is given to us as 2 meters, 2 meters. Here which is given to us as 3 meters each. 3 meters and 3 meters. Okay, so let's go ahead. These forces basically are going to get resolved as like this. This will be the x component, this will be the y component. Simply I'm keeping them resolved so that while doing the calculation it becomes easier for us. Again, this is the particular force and this resolved component like this. Okay, one by one let me write down the angles. This I'll be considering as theta 1, this I'll be considering as theta 2, and this particular angle to be considered as theta 3. Okay, so one by one I'll be writing down calculating the values of theta 1, theta 2 and theta 3 by using the trigonometry formulas. Theta 1 is equal to tan inverse of opposite, that is 6, divided by adjacent, that is nothing but 2. I'll keep it as it is, and whatever the value is there it will be calculated in degrees. Theta 2 is equal to tan inverse of modulus of, it will be opposite, again that is 3, divided by adjacent, that is 4. 2 plus 2 is 4. So here it is theta 2. Again, last but not the least, theta 3 is equal to tan inverse of modulus of the values of tan inverse of, here it will be opposite, that is 3, and adjacent, that is 2. So once we do the calculation one by one, we'll get the values. So theta 3 over here. Okay, let me get all the values one by one. So theta 1 was nothing but, let us directly calculate tan inverse of 6. Theta 1 was tan inverse of 6 divided by 2. 6 divided by 2, and the value is 71.565. So I can write it over here, 71.565 degrees. Same way theta 2 is tan inverse of 3 divided by 4, that is 36.869. It's better to remember this value. This is the most common value while we solve the problems. 36.869 degrees. Again, theta 3 is equal to tan inverse of 3 by 2. Theta 3 is tan inverse of 3 divided by 2. So here it is, 56.309 degrees. So 56.309, I can write it 56.309, or better I will be mentioning this as 56.31 degrees. Okay, let us go ahead, and similarly this could have been taken as 36.87 degrees, because 869 is there. So I'll be considering theta 2 is equal to 36.87 degrees. Okay, so same will be considered in the calculation. Let us go for step number 2. So now I'll be writing the step number 2 over here. Step 2 is summation of fx towards right to be considered as positive. Just before that, I'll be writing the values over here, because this was theta 3. So 722 cos of 53.31 degrees. This will be 722 sine of 53.31 degrees. Same way, 1000 cos of 36.87 degrees, should not forget to mention. Similarly over here, 1000 sine of 36.87 degrees. Okay, last but not the least, 622. So it was theta 1, 622 cos of 71.565, and over here 622 sine of 71.565. Okay, let us go ahead with the calculation one by one. Summation fx is equal to, now I will be mentioning it as 622 cos of 71.565 minus 722 cos of 53.31 plus 1000, this is the third component towards right, plus 1000 cos of 36.87 is equal to, let us go for the calculation over here. So it will be 622 cos of 71.565 minus 722 cos of 56.31 plus 1000 cos of 36.87 degrees. So here it is. Value comes out to 596.2. I can write it 596.2. So here it is 596.2 Newton. Value is positive, of course, so towards right. This was summation of Fx. Now step number 3, we will be going ahead. Step 3 is summation Fy acting in upward sense as positive. So it will be again equal to 1 by 1 will be taking 622 sine of 71.565 minus 722 sine of 53.31 minus 1000 sine of 36.87. So here it is, summation Fy is equal to, I can write it down now, do the calculation. So here it will be 622 sine of 71.565 minus 722 sine of 56.31 minus 1000 sine of 36.87 is equal to minus 610.66 is equal to minus 610.66. That is nothing but summation Fy is equal to 610.66 Newton downwards in downward sense. Now step number 4, it will be the calculation of R. Step 4, R is equal to root of summation of Fx square plus Fy square. Friends, as you all can see, the values are there in front of us. So therefore, R is equal to dash. How do I write it directly is nothing but squaring this term summation Fy plus 596.2 square of it is equal to whatever the value comes out to, square root of that answer, 853.44. So value comes out to 853.44. So now I'll be writing this 853.44 Newton. Of course, this is downwards sense, this is towards right. That is, the resultant will be acting towards fourth quadrant, making an angle alpha. Now, step number 5. Step number 5, let me write it over here, my dear friends. I'll just make this column so that things become easier for everyone to understand. So step 4, I'll be writing it over here. Step 5, sorry. Step 5 will be alpha is equal to tan inverse of modulus of summation Fy by summation Fx. So therefore, alpha is equal to tan inverse of modulus of 610.66 divided by 596.2. Okay, so let me just get the value. Therefore, alpha is equal to dash. So what is the value now exactly? Here it is. Tan inverse of 610.66 divided by 596.2. So here it is, the value 45.686 degrees. Can write it 45.686 degrees. We are done till here. Now I can erase this part because As of now, it is not required in the problem. Okay. So now, my dear friends, I'll be erasing this entire part and I'll be continuing with the values foundation of D, X and Y. So now let me start from here. So now location of step number 6, it will be the location of resultant. Step 6, location of R. Let R be located at a perpendicular distance small d to the right of B. That means since it is acting towards fourth quadrant, simply what we are assuming is let this resultant be passing somewhat like this from here like this. So this will be R, and let this perpendicular distance, if we consider, this will be the perpendicular distance of D to the right that we have considered of resultant. So now by Varignon's theorem, we will be going ahead by Varignon's theorem. Summation of moment of forces about B is equal to moment of resultant about the same point B. We are considering in clockwise sense as positive. So therefore, one by one, let us consider the forces about point B. So the ends are A, B, C and D over here. Now what we can do is, now just before going ahead, what are the forces for which the moments will be considered? Now 722 cos of 53.31 only will be considered. Again for this force only 622 sine of 71.56y will be considered. And last but not the least, for this particular force 1000 cos of 36.87 only will be considered, because rest of the components are directly acting at the point B. So let us consider them one by one. So minus 722 cos of 53.31 into 3. Again for this particular force minus 622 sine of 71.565 into 2. Last but not the least, it will be plus 1000 cos of 36.87 into, it will be, if I consider this particular force, so I am assuming it to be resolved over here, my dear friends. This particular force, it will be definitely resolved over here. That is why only X component is considered, and its distance is going to be 6 meters. So is equal to R. Vice versa, the same thing goes for the other forces. That means 722 cos of 53.31 is considered over here. It is given 622 sine of 71.565. It is actually assumed to be considered resolved at this particular point. X and Y components are resolved like this. That is why only Y component force is considered. Last but not the least, resultant R is 853.44 into D. Now friends, what is the value of D then? Let's calculate quickly. So I will be writing over here minus 722 cos of 56.31 into 3 minus 622 sine of 71.565 into 71.565 into 2 plus 1000 cos of 36.87 into 6 over here like this. So value is there divided by, what was the value of resultant? 853.44 divided by 853.44. So here it is 2.833 and the value is positive, that means our assumption is correct. So therefore D is equal to 2.833 meter to the right of B. So friends, once we are done, let us get the values of X and Y. So for that, simply I'll be erasing this particular area. Just to get this, let me just show it to you, my dear friends. I'll be just marking some of the points. This is point B. Let me consider this wherever it is intersecting this line of D. This is P, this is Q, and this will be R. Now let's go ahead by considering the right angled triangles to get the values of X and Y. So I will be writing it over here, and even my dear friends, this distance from B to C, wherever it intersects over here, this distance will be considered to be X. This is X that we are supposed to find. Same way, my dear friends, wherever this R point is located, this particular distance will be Y. So we are supposed to find this X and Y now. So now, my dear friends, let's go ahead. But I will be writing this as step number 7. So step 7, what do I write? In right angled triangle BPQ, in right angle triangle BPQ, if you can see, my dear friends, very clearly, this is the angle theta that I am angle alpha of the resultant. So it will be written as sine of alpha is equal to opposite, which is nothing but D, divided by hypotenuse, which is nothing but X. So therefore X is equal to D divided by sine of 45.686 degrees. Let me better show this angle of this like this, alpha. Okay, so here it is, D divided by, D is already there, divided by sine of 45.686. 45.686. So here it is. Okay, 3.96 meter is the answer. So X is equal to 3.96 meter. 3.96 meter. Just before erasing this step number 2, my dear friends, let me just write it down, the mark of this. This will be in university paper, this particular step is for 1 mark. Later on I'll be showing it for other steps. Just let me just erase this and I will be getting the value of Y over there. So now in triangle RBQ, in right angled triangle RBQ, again we will be considering the same angle, but the formula will be tan alpha is opposite, that is Y, divided by adjacent, that is X. Therefore from this, Y is equal to X into tan alpha. So X is already there, so I'll be multiplying the value X into tan of 45.686. Here it is, 4.056 meter is the answer. 4.056 meter. So friends, if you see the entire problem, the marks distribution will be 1 mark for this, summation fx with the right value, summation fy, r and theta, r and alpha, along with this, both of them will be getting 0.5 marks each for this, 0.5 mark for this. 1 mark you will be getting for D. So 4 till here, 1 mark for X, And finally, last but not the least, 1 mark for y. So this is how the 6 marks are going to get covered, my dear friends. And this is the way how the problem is going to get completed. So please do like, subscribe and share this video. Thank you for watching this video.